Hello everyone, thank you for joining me in this video for inscribed polygons within a circle. This is a continuation of the notes focusing on central and inscribed angles, and the polygons that we're actually just going to be focusing on will be quadrilaterals. One thing to remember about quadrilaterals is that there are 360 degrees inside the quadrilaterals between these four angles, and given that there's 360 degrees also in a circle, there's going to be a relationship certainly between angle measures, especially when technically you do also have inscribed angles at angle B that creates this arc, this major arc over here. Angle C is an inscribed angle creating this arc. There's definitely lots of angle relationships. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So we're talking about angle B and A, or D, sorry, those are opposite, and then C and A are also opposite angles. So remember that supplementary means to add to equal 180 degrees. So angle A plus angle C, they're not congruent, they are supplementary. So those two angles add to equal 180. B and D also add to equal 180 degrees. So let's go ahead and use that information to find missing angle measures in the given problems. Okay, so starting to find the measure of angle J is opposite angle L over here. It's next to angle K, and it's also adjacent to angle M. Those two are next to it. So L is going to be the angle measure that it is opposite. So those are the angles that will create the 180 degrees supplementary. So I'm just going to take 180 and I'm going to subtract 92, and that's going to be 88 degrees. Moving on to find the measure of angle K. K is opposite of angle M, which is 45 degrees, so they are supplementary. So I'm going to subtract 45 from 180 to get 135 degrees. Number 18 has a little bit more going on here because 93 degrees is, this angle S is an inscribed angle, so that's going to give me information about the measure of this major arc here, and then I have some other arcs also. So if I'm finding the measure of angle Q, that could help me with supplementary, but there's going to be a little bit more work to be done, so I'm going to zoom in on number 18 here. All right, first, please notice that I did fill in a little measure of angle Q here, so we do find all four angles. I'm going to fill in the ones that are probably a little faster to start. So the measure of angle S is pretty quick because that's already given as 93. So measure of angle S is 93 degrees. And then the measure of angle Q is going to be next because that's just going to be 180 subtract 93, which should be 87 degrees. Sorry, I don't know why I wrote squared there. That needs to be a degree symbol. So S and Q were pretty straightforward because I have S and then Q is opposite of S and those angles are supplementary. P and R are going to be a little bit more work because I don't have either of them, but I do have arc measures and they are inscribed angles. So I'm going to start with the measure of angle R because R is the inscribed angle that creates this intercepted arc. So 90 plus 126 is 216 degrees. So that's the measure of this whole major arc QPS. I'm going to divide that by 2, and I'm going to label that measure of angle R is actually 108 degrees because that's half of 216. So the measure of angle R is 108 degrees. And then from there, I'm going to find the measure of angle P by doing 180 subtracting 108 because these opposite angles, those opposite angles are supplementary. So 180 minus 108 is 72 degrees. So a combination of work as far as, or a combination of properties. We have our opposite angles being supplementary, use that 2 times. And then I use the inscribed angle relationship with the intercepted arc, that it's half of its intercepted arc to find these all four angle measures. Okay, so for number 19, we actually have a couple options. Considering this is the part of the lesson dealing with the inscribed quadrilaterals and the fact that their opposite angles are supplementary, I'm going to show you that method first, and then I'm going to do number 19 again using probably a method that's a little bit faster with the inscribed angle measures. But using the property that the opposite angles are supplementary, I'm going to try to find first angle N here. And that angle N is going to be half of this arc that it's creating, because that is the inscribed angle. Angle N is the inscribed angle of this arc. So 91 plus 135 is 226 degrees. So that's the total of this major arc. Divide that by 2, that makes it 113 degrees. So that means that my equation I can use for x would be that 15x minus 23 plus 113 equals 180. And again, that relationship is coming from the opposite angles being supplementary. So 15x minus 23 for angle L is going to add with the 113 degrees to be supplementary 180 degrees. Solving this equation, combining like terms and subtracting from 180, we get 90. 15x equals 90 divided by 15, x equals 6. So again, that's a method that's using the opposite angles being supplementary within a quadrilateral that is inscribed in a circle. The second way to do this is really to ignore the fact that it's a quadrilateral. Like these segments over here are not really affecting the measure of angle L and being able to find x. So what I'm going to do is I'm going to focus on this arc here, on the finding of that measure, because that it has a relationship with the measure of angle L. So I'm going to take the 360 degrees and I'm going to subtract the 135 and the 91. And when I do that, I get 134 degrees. So that's the measure of this arc out here, which then when I would divide that by 2, that means that this 15x minus 23 on the inside, or sorry, in the inscribed angle, 15x minus 23 is going to equal 67. And again, the 67 is from taking the 134 and dividing by 2. So when I solve this, add 23 to both sides, I get 90, x equals 6, just like in the last one. So just a different way to do it. So this one uses the inscribed angle relationship with its intercepted arc and doesn't address the quadrilateral at all. This problem for number 20 is simply just a heavy algebra problem. I'm given an expression for the measure of angle W and the measure of angle Y, which are supplementary because they are opposite of each other. The thing with number 20 is that we just want to make sure we answer the final question of finding the measure of angle Y. So the initial relationship that I have is the supplementary. So 5x plus 1 plus 13x minus 37 equals 180 degrees because the opposite angles are supplementary. So I'm going to solve this by combining like terms and solving for x. So solving for x looks like combining like terms, 18x minus 36 equals 180, adding 36 to both sides, and then dividing by 18, x equals 12. We are focusing on the measure of angle y here, so that means I'm going to take the 12 and plug it in for x in that expression. So the measure of angle y is going to equal 119 degrees. Okay, we're ready to practice what we've covered here with the inscribed polygons. You do have a practice worksheet in your folder that also will focus on the central and inscribed angles as well as the polygons. The Canvas assignment will focus on polygons. So I want you today to be working on the Canvas assignment. Please understand that there's going to be inscribed quadrilaterals, which is what this lesson was on, and focus on that special property that opposite angles are supplementary. But you could also have triangles as well. But with the triangles, there's nothing new. There's no special property. You're just using all of the properties you know about triangles, that there's 180 degrees inside of them. But you are also using that in the fact that there are inscribed angles into the onto the circle, creating those arcs. So I'm not covering anything special about triangles because there's no additional special properties like there are with the quadrilaterals. So please understand you will see triangles also, and that is not a gotcha. I'm just trying to show you that you do already know enough information to find the answers with the triangles because there's no special properties. The only special property that we covered in this lesson is that opposite angles are supplementary for the quadrilaterals. Thank you for watching this video about inscribed quadrilaterals in circles. If you would like some extra credit, go ahead and email me and tell me that the name of my dog is Penny.